Hello everyone, so this is our performance test for second quarter in general mathematics.
Nominal interest rate is the annual interest rate per year for a certain compounding period. Nominal interest rate can be applied to the advertised or stated interest rate on a loan, without taking into account any fees or compounding of interest. The nominal interest rate can be calculated using the formula J equals IN, where I stands for the periodic interest rate, the J, the nominal stated rate, and the number of compounding periods. Here's the example problem. What is the nominal rate of interest on a company that has 9.99% rate of effective interest annually? Since we're looking for the nominal rate of interest for determining J, first we can identify the information that is given in the problem. The N, the number of compounding periods, 12 or months per year. In the I, the periodic interest rate is 9.99% or 0.0999 to change it into decimal point. We can use the effective interest rate formula 1 I or I equals open parenthesis 1 plus J over N plus parenthesis raised to N minus 1. Substitute the above values and solve for R. 0.9999 equals open parentheses plus J 12 over close parentheses and raised to 12 minus 1. Second step is the negative 1 in the right side. Move to the left side. Negative will change into positive 1, so it will become 0.999 plus 1 equals open parentheses 1 plus J over 12 close parentheses 12 raised to 12. Third step is the 1 inside the parentheses. Move to the left side too, and positive will change into negative, and the raised to 2 will move into left side too. Kung sa matira na lang sa right side is the J over 12, and divided by 12 both sides. There's a cancellation in the right side at ang natira na lang is the J. And for the final, I used the calculator to solve it, and the final answer is 0.0956, and rewrite it to percentage, and it will become 9.56%. So the nominal rate of interest in company that has a 9.99% effective rate or compounded annual per year is 9.56% compounded monthly per year. That's all for the nominal rate. Thank you.
Good day, I'm Jasmine Vitanyoso. I'm going to talk about ordinary annuity. Ordinary annuity is a type of annuity that pays out the conclusion of each interval period. It is also a series of regular payments, such as monthly or quarterly, made at the conclusion of each period. Funds on an annuity due, on the other hand, are made at the start of each term. The present value of an ordinary annuity is crucial. The concept of present value, sometimes known as the time value of money, states that money is worth more the sooner you get it. The more money is worth in any given deal, the longer you can hold onto a payment or the sooner you can collect it. This is due to the fact that the longer you have that money, the longer you can put it to work for you. Ordinary annuity formula. Present value of ordinary annuity beginning. And for the present value of ordinary annuity end. Example problem. Carsley has inherited 500,000 as per the agreement. However, the agreement stated that the payment would be received in equal installments as an annuity for the next 25 years. You are required to calculate the amount that shall be received by Carsley. Assuming the interest rate prevailing in the market is 7%. You can assume that annuity is paid at the end of the year. Based on the problem, we are going to use the present value of ordinary annuity end. Solution. This is the following data that can be used for calculation.
Simple and general, this type of annuity where payments are made at the beginning of each payment period. For example, when paying rent, the payment is due at the beginning of each month. To the look for deposit and payment made at the beginning of each month. Payments made in advance. Payments starting today, due at the beginning. Simple annuities due are annuities where payments are made at the beginning of each period and the compounding period is equal to the payment period. Annuities due are annuities where payments are made at the beginning of each period but the compounding period is not equal to the payment period. Annuity due is an annuity whose payment is due immediately at the beginning of each period. A common example of annuity due payment is rent paid at the beginning of each month. A deposit of $100 is placed into a college fund at the beginning of every month for 10 years. The fund earned 99% annual interest compounded monthly and paid at the end of month. How much is in the account right after the last deposit? The value of the initial deposit is $100, so A1 equal 100. A total of 120 monthly deposits are made in the 10 years, so N equal 120, N equal 120. To find R, divide the annual interest rate by 12 to find the monthly interest rate and add 1 to represent the new monthly deposit. R equals 1 plus 0.09 over 12 equals 1.0075. Substitute A1 equal 100, R equal 1.0075, and N equal 120 into the formula for the sum of the first n terms of a geometric series and simplify to find the value of the annuity. S120 equals 100 open parentheses 1 minus 1.0075 raised to 120 close parentheses over 1 minus 1.0075, and the answer is 19,351 and 43 centavos. So the account has $19,351 and 43 centavos after the last deposit is made.
Hi, I'm Angelo Ken Martin, here to explain annuity certain. Annuity certain. An annuity whose term is fixed when the term starts and ends in a definite date. The payments are to continue for a specified numbers of payments, and calculations are based on the assumption that each payment is certain to be made when due. Here's our example. Andrew Maguire started to deposit 1,200 monthly in a fund that pays 6% compounded quarterly. How much will be in a fund after 10 years? Our given is R equals 1,200, N equals 1 on 20, I equals 0.06, M equals 4, F is unknown. Our step one is to convert 6% compounded quarterly to its equivalent interest rate for monthly payment interval, like this. Substitute the interest to 0.06 divided by 4, which equals to 1%, 0.15 in the power of 4. Do the compounded quarterly. So we got this 1.0.15 for the raised to the power of 1/3 equals that is to 1.00497 5.1 but minus 1, which gonna go to our interest equals 0.00497.21. Our step 2 is to apply the formula f equals r 1 plus interest to the raised to the n minus 1 over I. In finding the future value of an ordinary annuity using the computed equivalent rate, is f equals, substitute the formula into the here. So the 1200 1 plus 0.004975.1 raised to the 120 minus 1 over divided I mean 0.00497.1, and answer this, we will get f equals 1200 0.81981401922 over 0.004975.1. Answer that as well, then we will get the final answer. F equals 1200 163.6115.04741. Therefore, Andrew McGrew final final fun is this. That's all. Thank you.
Good day everyone, I'm Faith Gracia from STEM 14E. Today I'm going to present to you my presentation of contingent annuity, the concept of it, and example problems on simple and general annuity. So first, this is the concept of contingent annuity. Annuities are financial products that pay a fixed income stream to an individual and are commonly used by retirees. A contingent annuitant is someone designated by an annuitant to receive the annuitant's payment when they pass away. Before we proceed to the example problems, let me tell you what is the contingent annuity. Contingent annuity is an annuity in which the payments extend over an indefinite length of time. So let's proceed to the example problems. Here's the example problem of simple annuity according to payment interval and interest period. Rose works very hard because she wants to have enough money in her retirement account when she reaches age 60. She wants to withdraw 36,000 pesos every 3 months for 20 years starting 3 months after she retires. How much must Rose deposit at retirement at 12% per year compounded quarterly for the annuity? Here's the given example in a simple annuity. Periodic payment R is equal to 36,000. Interest rate per annum R is equal to 0.12. Term T is equal to 20 years. Number of conversion per year M is equal to 4. N equals M times term is equal to 20 multiplied by 4 is equal to 80. The interest rate per period is I equals to R divided by M. 12% is converted to these decimal points, which 0.12, so that the interest rate per period is I equal to R divided by M is equal to 0.12 divided by 4 is equal to 0.3. Next, we need to find the present value. Since it indicates here that every 3 months she needs to withdraw 36,000 when she became age of 60. So therefore, present value is what we need to solve in this problem. The formula of present value is P is equal to periodic payment 1 minus quantity 1 plus I, quantity raised to negative n divided by I. Periodic payments is equal to 36,001 minus quantity 1 plus 0.03, quantity raised to negative 80 divided by 0.03. So the answer for present value is 1,087,227.48. Thank you for watching and listening.